Lee Teschler with EE World and Design World, and I'm here with Len Crane from Coilcraft, and we're talking about transformers. Now, Len, I always thought that you've seen one transformer, you've seen them all, but actually some don't look like transformers, and there's also a more general term for them called a coupled inductor. Can you sort this out for us? What's the difference between a transformer and a coupled inductor?
Well, we can try. Generally, the term coupled inductor is used in applications where the magnetic device, is expected to store energy, and then it is sort of released through a second winding, as opposed to generally transformers thought of even like a 50, 60 hertz transformer, where the power goes in and it immediately comes out by the turns ratio, let's say. Whereas a coupled inductor is really designed more of a pulse type application, a flyback. People usually call flyback transformers, and they're really coupled inductors.
Now, those two different applications, are they both designed the same way?
No, they're designed slightly differently, and it affects the number of turns and the ratio because they operate slightly differently. In a forward mode transformer, really the output is dependent mostly on the turns ratio and the duty cycle. In a flyback or a SEPIC or other coupled inductor applications, it depends on the transformer turns ratio, but it does not always have such a straightforward relationship with the duty cycle, for example. It's dependent on input voltage, output voltage. So we store energy, and then the energy is drawn out of the secondary winding for a variety of applications and topologies.
And I understand it used to be that coupled inductors, they were basically custom-made parts, but not so much anymore, right?
That's right. That's one of the things we're really working on, is to try and offer more standard products for two reasons. It's certainly time to market for the customers. It expedites their selection. Here it's already done. And if they're pre-designed off the shelf, that gives us the opportunity as a manufacturer to design them better for manufacturing and reliability, low cost, obviously, and in particular with transformers or coupled inductors now, size. So we can really optimize the design, whereas often if it's a quick turnaround in a custom design situation, it's less likely to be truly optimized, especially in a quick design cycle situation.
And some of these designs, I'm surprised, they're actually really tiny. Could you talk about that a little bit for us?
Right, and what we at Coilcraft have done is we've adopted really the manufacturing techniques and design types from the single inductor type magnetics. So we didn't really start with the typical transformer bobbins and try and shrink them, but we started with the single winding inductors, which are very much optimized in terms of packing factor, really miniature inductors, and we've seen wire wound inductors shrink down on the RF side of things, to tiny, almost invisible sizes. So we've developed a line of coupled inductors based on those type of technologies in both 1-to-1 ratios as well as interesting turns ratios, let's say. And they're really significantly size reduced in clean shapes and especially low profile in nature.
I see. We've got some examples here behind us. Could you kind of tell us what we're looking at?
Sure. A couple things. First of all, we're offering a lot of these parts in a designer's kit. So designers can select from a range of inductance values. They're all 1-to-1 turns ratios, and select those parts, and in a variety of sizes. And then we also have, one of our featured products is LPD 5030V. The V, standing for high voltage isolation, offers up to 1,000 volts of winding to winding isolation in a very small form factor. It's really kind of amazing. If you see that next to what we think of as a transformer, you probably wouldn't recognize those as the same type device.
Yeah, it really is pretty small. What are the dimensions on that?
We have standard products as low as 3 by 3 millimeters in footprint, and as low as 1 millimeter in height. Very popular sizes range in 3, 4, 5 millimeter footprints. Really low profile from say 1 to 3 millimeters is very common.
Len, that's pretty interesting. I had no idea that coupled inductor technology had progressed to that degree. Thank you.
Thank you. Thanks, Lee.